Okay, so the zero exponent rule, which you guys saw in the warm-up, and then we're going to take a look at how to work with negative exponents. What we're looking for is to have nothing but positive exponents in our final answer. We're going to introduce dividing with exponents tomorrow, and that's going to allow us to do a little bit more with our negatives and make sure that we're getting those positive exponents. So if we take a look, you guys had 2 to the third equals 8, 2 to the second equals 4, 2 to the first equals 2. You guys already had that on your paper. So what was 2 to the 0? 1. What was 2 to the negative 1? 0.5. I told you you had to turn it into a fraction. So what is 0.5 as a fraction? Equals 1/2. So our first negative exponent didn't give us a negative number. It gave us a fraction. What's 2 to the negative 2? 1/4. So once again, negative exponent didn't give us a negative number. It gave us a fraction. And what's 2 to the negative third? 1/8. Ladies and gentlemen, do we notice any patterns, any relationships that are happening in our table? Nate?
The denominator doubles.
The denominator continues to double. So notice here, as we move from the power of 1 to the power of 2 to the power of 3, did these double? Yeah. Did these continue to double, but only in the denominator? All right. Anything else? Anyone notice anything else? Darwin?
Oh, it's like, as I was about to say that the denominators keep doubling down.
Yep, they keep doubling down. That's the same thing Nate saw. I want you guys to look at these two answers. 2 to the first and 2 to the negative 1. Do you guys notice any relationship there between those numbers? Between the number 2 and the number 1/2? What about the 4 and the 1/4? What about the 8 and the 1/8? There's a word that we used quite a bit in chapter 5. Oh, Devin, what were you going to say? Reciprocal. Ladies and gentlemen, that's all a negative exponent does. It simply takes the reciprocal of that positive power. So it's going to take that value and it moves it to the denominator. It takes the reciprocal. And so that's going to be the rule that we work with when we're using our negative exponents. There is a little video. I probably won't show that to you guys today because the paper folding took time that I hadn't planned previous years. But this is one of my favorite quotes from Einstein. Do not worry about your difficulties in mathematics. I can assure you that mine are still greater. So I always keep that in mind when I'm struggling with something that even Einstein had problems. I know. All right, so ladies and gentlemen, let's take a look at our negative exponent rules. I kind of moved these around on your notes today because we'd already done that rule. A negative exponent. To eliminate negative exponents, and that's all you're doing, guys. You're not really operating with negative exponents. You're trying to eliminate them. And so what we're going to do is we're going to rewrite the problem as reciprocals. So what that means is if you had a to the negative m power, you would write that as 1 over a to the m. Anytime we take the reciprocal of 2, it's 1/2. The reciprocal of 8 was 1/8. So now what we want to do is take a look at this example here. We have x to the third, positive exponent. I don't need to do anything with that x to the third. But I have y to the negative 2, and I have z to the negative 5th. I have to rewrite those. And so x to the third gets to stay where it's at. If it's here, it's going to stay in the numerator. But then y to the negative 2 moves to the denominator. That's what happens when we take a reciprocal. And z to the negative 5th moves down. And notice nothing changed except those negative exponents became positive. There's no operating that we do with them. We're not evaluating anything. We're simply rewriting it as a positive exponent. Okay? And then your zero exponent rules, guys, I think you already had these. That anything to the 0 power is 1. So we did the paper fold. If we have a piece of paper and we do 0 folds, we have 1 rectangle. So whether it's a variable, a piece of paper, whether it's an entire expression. So if you look at that example, we have the quantity 3xy. Everything in here is being raised to the 0 power. So this whole expression just becomes the number 1. All right? So let's take a look at some of the examples I want you guys to do. So the first one we want to do is x to the negative third. I need to rewrite it so that I only have a positive exponent. So what am I going to do? Take the reciprocal. Yeah.
should you put x to the negative third at the denominator?
I'm not going to put x to the negative third in the denominator. I'm going to put x to the positive third. That's what happens when we take the reciprocal, is it becomes a positive exponent. If you look back here, what happened to the a to the m, a to the negative m? It became positive. What happened to y to the negative 2? It became y to the positive. Z to the negative 5th was z to the positive 5. And that's what we're supposed to see here in this table, is that 2 to the negative 2 was just 2 squared in the denominator. 2 squared was 4, so 4 went in the denominator. There was no negative value there anymore. 2 to the negative third, we took 2 to the third and put it in the denominator. So when I have x to the negative third, I'm going to take x to the third and put it in the denominator. What are we going to do with number 2? Which one should get my focus? Which one am I trying to eliminate? Will? A to the negative fourth. So b to the 7th can stay where it's at. And a to the negative fourth is going to go to the denominator. And Isaac, what happens when I move it to the denominator? We okay with that, ladies and gentlemen? That's all we're moving. There's no fancy rules of adding exponents together or canceling or anything. All we're doing here today is moving things from numerator to denominator. Or if we look at number 3, I can take the reciprocal by moving things from denominator to numerator. A to the negative 2 should be getting my attention, and c to the negative 4th should be what gets my attention. Those should be the things that catch my eye. B to the third can stay where it's at. Remember what I said about taking reciprocals, guys? The reciprocal of 2, is 1/2. But the reciprocal of 1/2 is simply 2. So you can take the reciprocal of something that's in the denominator already. You can make it into a whole number. So this a to the negative 2, I have to take the reciprocal. So if it's in the numerator, it moves to the denominator. What's going to happen with this c to the negative 4th when I take the reciprocal of it? It's going to move up. Guys, I use the word reciprocal a lot. Or the word reciprocal is how we define it. I end up using the word flip a lot. I flip a to the denominator. I flip c to the numerator. I'm moving their positions around. So remember, b to the third didn't need to change. B to the third gets to stay in the numerator. What joins it in the numerator? C to the fourth, and it's a positive when it moves up there. Is there anything in our denominator? Did we have to move anything down? Abby's shaking her head. I'm going to guess she's shaking it because we need an a squared down there. How many people have that already? You guys rock. All right. Number 4. You guys could probably type this into like a askmath.com or a couple of different places. And there's a couple of different strategies that look at how to do this. I don't always trust those sites because I did find one that gave the wrong answer. So I wouldn't try that all the time. But it's not always a bad try to see how they explain it because they do a good job explaining those. What I'm going to do here, ladies and gentlemen, is I'm going to combine our rule from yesterday with what we're learning today about negative exponents. So remember, if I have a quantity raised to a power, everything in here gets raised to the negative 2 power by multiplying. So this is going to become 3 to the negative 2 power. X is already squared, and when we multiply those, I get x to the negative 4. And now when I have y to the negative 4th, and I raise that to the negative 2 power, I'm just multiplying those exponents. So I get y to the positive 8. What I find, ladies and gentlemen, is when we have a negative exponent outside of our parentheses, if I don't apply that, if I don't use that power of a power rule, what happens is I end up flipping things like 2 times. Here, if I apply that power inside, I only have to move things once. Grace?
Do we have to simplify the reading the negative?
Yes, and I'm going to explain to you what I want you guys to do. I don't want you using negative exponents on your calculator ever. The only thing you're going to type in are positive exponents. Because what we're going to do here, ladies and gentlemen, before we grab our calculator, is we're going to eliminate these negative exponents. How do I eliminate those negative exponents?
Make them too positive.
How do I make them positive? Can I just erase the negative and call it good? I have to move it. I have to take the reciprocal, right? So what's going to stay in the numerator here? y to the 8. What's going to be in my denominator? 3 to the second and x to the fourth. So Grace, you are going to need to evaluate that 3, but it's going to be with a positive exponent. And so more than likely, you're not going to need your calculator for 3 squared, right guys? So what I can do now is we're going to wrap this up with a final answer of y to the 8th over 9 x to the 4th. Okay? What happens is your calculator is going to give you a fraction or a decimal for that, and we have trouble figuring out where that number goes. But if all I ever have are positive exponents, and I have those values in the right position, I know where 9 goes. 3 squared was in the denominator, so I know I have to have a 9 in my denominator. What?
Like the y became 8 is in multiplication.
Yep, that's our rule here. When you have a power raised to a power, you multiply those exponents. That was one of the things that we talked about yesterday. Alexis.
What would happen if it was like 9y to the 8 and then like 3x to the 4? Like what would you do with the 9 and
Okay, read that column off to me one more time.
what if it was 9y to the 8 over 3x to the 4? Like what would you
What would we do with that, guys? Does anyone have any ideas to what we could do with that?
Who can be divided?
You will. You'll divide this. More than likely, you won't see much of that today because tomorrow's our dividing rule, so we're not going to see much that simplifies. But those coefficients, remember, just like yesterday, we multiplied them. Today, if we have coefficients, we're just going to divide them. Good question, Alexis. All right. Here's your assignment, ladies and gentlemen. You're doing number 2. You are then doing numbers 15 through 27 multiples of 3. So 15, 18, 21, 24, 27. And then 30 through 45 all